again, let's look at some more examples of higher degree polynomial equations. These do not have the quadratic form, so we'll have to use other techniques to solve them. Let's start with this first one. 3y cubed plus 16y squared equals 12y. Right, we see this is a polynomial equation of degree 3. And first thing we'd like to do is let's get everything on one side equal to 0. So we have 3y cubed plus 16y, and then we're going to subtract the 12y, so minus 12y equals 0. Okay, now this is not a quadratic, so we can't use the quadratic formula on it. But the first thing we should do when we're attempting to solve a polynomial equation is to factor out any common factor from the terms. And we see that each of these does have a common factor, and that's a factor of y. So we can factor out the y first, so y, and then write down what's left here. So if we factor y out of 3y cubed, we're going to get 3y squared plus 16y minus 12 equals 0. Good. Okay, and now we can take this and, well, we can use now the zero product property. We have y times this polynomial equal to 0. That means y equals 0 solves this equation. Or any solutions to this will also solve the equation. Okay, so we'll start with that. Y equals 0. Okay. Or 3y squared plus 16y minus 12 equals 0. Okay, we've got that solution, 0. Now we need to solve this. And the way we can do that, we can try to factor that. If you're familiar with the AC method, you could do that. I think we'll just use the quadratic formula. So we have x equals negative b, so negative 16, plus or minus the square root of b squared, so 16 squared, minus 4ac all over 2a. 2 times 3. There we go. Okay, if you're careful with your calculator, you can go ahead and plug this in and evaluate it at both the plus and the minus. I'll give you, I suggest if you've got your calculator, this is good practice to do this. So go ahead and pause the video and work this out. Okay, how'd you do? I have the answer over here. Let's see. So we get x equals 2/3 and negative 6. All right. You can now take these and plug them into your original equation and see if they do solve the equation. Another thing, the variable that we have here in our equation is y, so I want to use y instead of x. And one more thing is we have this solution of 0. We should also include that in our solution set. Good. Okay. Next example. Here we have y cubed plus 4y squared minus 9y minus 36 equals 0. This one, right, again, we want to look for common factors. So we've got y cubed, 4y squared, so y squared minus 9y, so y minus 36. Okay, we have no common factors. That's fine. Here we have 4 terms, and so we try to look for a way to factor by grouping, if possible. Factoring by grouping means we look at just 2 of the terms, or by pairs, and see if there's any common factors between them. If we look at the first two terms, we see that y squared is a common factor. So if we take out a y squared from this term, we're left with y. A y squared from this term gives us plus 4. All right, if we look at the next two terms, we see there's common factors. We've got a 9, negative 9 actually, and there's a negative 9 in 36 as well. So we'll factor that out. So minus 9 times y, and then if we factor out a negative 9 from negative 36, we're left with plus 4. All right. This is very good because these terms, y plus 4's, match in these two terms. So we can factor those out, and we'll be left with a factorization for this polynomial. All right. So we're going to factor out the y plus 4. So we've got y plus 4 times y squared minus 9. All right, so y plus 4 times y squared minus 9 equals 0. We can set both of these equal to 0 and solve them. So y plus 4 equals 0, or y squared minus 9 equals 0. That's y equals negative 4, or y squared equals 9, which means y equals plus or minus 3. It gives us solution set y equals 4, 3, and negative 3. Okay, last example, x to the 4th equals 4. Here, we can get everything on one side, so 4 minus 4 equals 0, and then factor this as the difference of two squares. X squared plus 2 times x squared minus 2. And then we can solve each one of these. So very similar to the quadratic form, here we're letting the a, or the thing that is squared, be x squared. All right, so x squared plus 2 equals 0. That's x squared equals negative 2, or x equals plus or minus square root of 2, or I times the square root of 2. X squared minus 2 equals 0. X squared equals 2. X equals plus or minus the square root of 2. All right, so our solutions are plus or minus 2i. So square root of 2 minus square root of 2, I times the square root of 2, and minus I times the square root of 2. All right, so we've looked at higher degree polynomial equations of quadratic form. We've done an example here where we just have some basic factoring that gets it down to a quadratic, and we can use all our tools to solve a quadratic. We have this example of factoring by grouping. That happens when there's, or could happen when there are 4 terms that you see. And then another opportunity to use the quadratic form, perhaps hidden in this x squared, x to the 4th equals 4.